a centralized store. And we're using a cloud storage for this purpose. We're using a Cassandra database that lives across Azure and Google Compute Engine. This could also, reside on premise, but for our scalability purposes and the way that we're serving this to our customers, which are, again, mostly in private industry, this really makes a lot of sense for them. The data is all encrypted at rest inside the Cassandra database, and we're able to, quickly across the entire, we've customers that have petabytes of data that in millions of files that they're now able to quickly search and get results back that are highly personalized in a very short period of time. So by taking this approach, essentially we get three main benefits for the customers that we're servicing. They get the anywhere access that you'd expect from something like a cloud storage, while being able to keep data on premise in a NAS type of environment. They are able to experience much faster file transfer and sharing using this technology. The way that we built the product was essentially to start by producing a transport layer that allows very rapid extraction of data from an on-premise environment. And so the customers take advantage of that if they need to move data from long distances and large amounts of data. And the kind of a cool consequence that you get from having a singular schema to attach to any source of data is that you can then inject that into other type SaaS services like Microsoft Office Online. So you can quickly take any file that's living anywhere across the enterprise and open it up for co-editing and co-authoring inside Office Online. Obviously, now that you've got a massive Cassandra database that's full of all this metadata, you could take advantage of analytics that are available for that kind of a service. So, particularly, we adopted the SMAC stack, which includes Cassandra as a piece of it, but also has Spark. And the nice thing that we can do there is enable a very personalized, individualized search for each user with that advanced analytics. And what we've been finding is that the customers that we've deployed this to are really happy with the speed that they're getting responses back and the personalization of the response. So if there's a particular piece of information that they're looking for, keep in mind this is something that we've been seeing across industry for quite a while. As these data sources grow, people are spending way more time looking for data than actually doing work. And it's been, some of the stats that we've seen are something like 20% of people's time is spent just looking for that file that they don't remember if they left it on Dropbox or if the latest version wasn't an email or whatnot. So it's definitely helped, our users to be far more productive. And finally, the last piece that we find really interesting that we're kind of driving into this as our next endeavor is around audit and governance. So now that you have all this information about access patterns, the usage of data, you can do some fast analytics and discover, say some usage patterns or patterns of behavior that may indicate you've got a leak in the environment or you've got a hacker that's penetrated into the environment. Essentially, being able to attach to all these different sources of data, extract all the metadata into a single centralized place and very quickly keep that metadata index up to date really gives you a lot more power for what kind of services you're able to deliver on top of a really large namespace for any organization. So that's all I had. It was kind of a whirlwind, so please, if anyone has a question, let me know.
Okay, thank you, Mitch. I'm going to ask, I'll ask a quick first question. Can you give us like the 1 minute or 30-second 1 minute, just rough, at a high level that you're comfortable with? Just kind of where does the technology sit and how roughly kind of how it works?
Sure. I'll give it really quick. So essentially, imagine you've got a virtual appliance or an agent that's running on-premise or in the cloud if you're attaching to a cloud silo. The agent, you'd think of it like a scanner, indexer, and language processor. And that, think of that as the the singular agent that's going to be feeding all of the disparate sources up into a centralized cloud. And the centralized cloud is where the index is stored and keyed based on our customer ID and other sources to make sure that we're not cross-pollinating. But the cool thing is that we can actually take that massive store that's across multiple of our customers. So we're talking about the order of billions of file objects at this point, and we can actually do machine learning across the entire set of data and not have to singularly attach onto a single customer or a single data silo to try to understand the patterns of behavior. So.
I actually have a million questions, but I'll just ask you a couple. Firstly, it sounds totally clever. I love it. To the question of where it sits, does it run on every desktop, or is there a place centrally where it can gather all the good stuff?
So it can run on every desktop. We have deployed that way in one environment where they wanted to have desktop sync type of features. But for most of our customers, we simply run a single virtual machine that sits next to, say, a NetApp filer and sucks the data out of it.
Okay, so the presumption is that you've got centralized storage somewhere.
Correct, yes.
Cool. All right, so the stuff that I've been doing is sort of trying to take totally unstructured file systems and make them behave kind of like object stores, and I hate to use those words so glibly in an audience of technologists, but for my purposes, an object is just a piece of data that you can individually address and manipulate, and it has an address. So I'm wondering if there's any way to create like a persistent address across this huge collection of files so that those files could be externally referenced and you could know stuff and do stuff about them that sort of transcends the user's ownership of that file.
That's exactly what we've done. So essentially, we've hashed every path that we encounter, and that hash is it's this UUID essentially gets stored in a Cassandra database, and that indexes that file. And in another database, we're storing all of the keys that have been extracted using natural language processing, where the key is primary and the hash is actually a secondary column in the database. So now you can do a reverse lookup to say if I'm looking up football or something like that, then it's going to cross-index and find all of those UUIDs that are applicable to that key, and then it's going to use the machine learning process that we have to reorder and re-rank the data depending on your user and your user behavior, how you interact with that data, and other users that have used similar data, and return the result of files in that search.
Okay, great. One more question?
So I'm trying to understand how the user interfaces with your system. So a user just drops a file in Dropbox and you will find it out magically, and when he is looking for that file, he will not go to Dropbox. So what he's going to?
Yeah, so exactly right. So a user would simply go about using the files wherever he leaves them, and only at the time where he wants to find will he open up our app. We have web app, and we also have iOS and Android apps that, the problem is we call this the dude, where's my file problem. Right? I know I was working on this file. Did I leave it in Dropbox? Is the latest version in email? And simply entering in some keys, maybe another user that he was collaborating with into our app, then provides a link back to that original source of data where he could go ahead and download it, or he can create another shared link to send to another colleague.
All right, and with that, we'll conclude our morning sessions. Thank you again, Mitch. Take care. Thank you.